This is the third and last example of using flowchart proof. Remember that in flowchart proof we have to realize that we need to get three parts of one triangle congruent that lead to the triangles being congruent, and then we can say that their corresponding parts are congruent. And so in this particular case we see that it looks as though we have triangles that on the left and right would be the same size and would be congruent. Well, we have to prove that. That's basically going to be the proof. We're told that ray BP bisects angle ABC. Now I wrote a little 1 and 2 in here. That would mean that angle 1 and angle 2 are congruent. Okay, that's a little angle at the top of the triangles. And now this doesn't say they're congruent, so this is going to be one we're going to have to put something over here again. So the given will be here, and then that will produce a congruency that we write in this box. Remember, it's always three congruent parts in this box. Anything that produces a congruency is always to the left of it. We're also told that angle A and angle C are congruent. And we have to prove that with that information, the whole triangle is isosceles. So let's start out, we would again start out saying that BP bisects angle ABC. So this would be the first thing that we would write in our proof. And I'm just going to put that whole thing right over here. Okay, that BC, move this a little bit. That BC bisects angle ABC, and that would be, again, the reason for that would be given. And I'm just going to leave it like that. Okay, that's okay with me. And that, of course, means that angle 1 is congruent to angle 2. Okay, and that would be the definition of bisect. All right, and then the second thing is that angle A is congruent to angle C. And that would be, of course, given. And then we take a look at the triangles. Remember I said before, always look for a shared side. In this case, both triangles share side BP. So that would be the third thing that you would say, and that would be that that BP equals BP. Now this time, of course, we write them both in the same order because B to P is the same direction for both of these triangles. It's not, one's not reverse of the other. And now, of course, we see that the reason for this would be AS again. So angle, side. That would be two angles in the side opposite one of them. And so we can say that the triangles are the triangles here. Triangle, that can come out a little farther, ABP, I gotta change those again, is congruent to triangle, well, ABP is congruent to triangle going to triangle CBP. And of course we know the reason for that already is going to be AAS. There I go again. That little Greek thrown in there. Change that to okay. Let's say yes. And then, well, now we have to prove this isosceles. So you know all this stuff I've done so far. Really, it's like, well, how did you know? Well, I know that I had to get three things congruent, and I know that I had to use the information that was given. I should have said shared side here, shouldn't I? So I knew I had to use the information given, and I knew I had to well, do what I did here so far. But now I wonder what CP/CTC thing I should use. Well, now I take a look here at what I had to prove. And you might say, well, how do you do all that without knowing what you had to prove? And my answer to that would be, well, I know that since I'm doing with congruent triangles, I need to get two triangles congruent, and these are the only ones that I had to look at. So I just went right to it. And now that I got this far, what do I got to do? Well, we have to prove that triangle ABC is isosceles. Well, this goes back to what you might remember about isosceles. Isosceles triangles are triangles that have two sides the same length. And so, but the sides of the same length are going to be AB and B and CB. So once I prove AB and CB the same length, my triangle is automatically isosceles by definition. And so that's going to be the corresponding parts. I would say that AB equals CB. I'll put that where it belongs. And then, of course, the reason for that would be CP/CTC. And then finally, I can again say, well, that's going to lead to my final thing that I had to write, which is what I had to prove, which is always the way it ends up. The last thing you write is always what you had to prove. And that would be A, B, C is isosceles. And so that, there you have it. Again, on this one I had to do something before and something after my skeleton proof. But it's the same basic steps. You get triangles congruent because of three things, and then you have to go from there and put other information in as you need to show that what you did wasn't just all made up. And it shows the flow of thought on how you got to things congruent and how you ended up from the beginning to the end. So that's how you need to do on any problem. Look for a shared side. Look for vertical angles. Look for things like definition of isosceles or what parallel lines mean and what kind of congruencies that give you. And then you know that you got it done. That's all there is to it. So good luck on your flowchart proofs in the practice sheets ahead.